Basically, what we're talking about is like the different ways to improve and optimize AI's responses. How are they different from each other?
Every prompt that I'm writing, it's sort of like you want it to just complete your thought at the end of it. And you sort of specify as much as you can. People shouldn't be surprised if they're not writing evals today. I think it's totally common. Like every business on earth is just trying to figure out how to get AI into their product.
What are some basic tips to make this thing respond well?
I mean, it's useful to think of the system prompt separate from the main prompt.
Why does Meta think open source is gonna be the right solution here? Okay, welcome everyone. My guest today is Adam Loving, AI partner engineer at Meta. Adam has helped hundreds of companies integrate AI into their products. So I'm really excited to get him to do a technical deep dive on prompting, evals, retrieval augmented generation, fine-tuning, and just building great AI products in general. This is going to be a complete course on AI from Adam. So welcome, Adam. Yeah.
Thank you. Thank you.
Okay, so let's take a step back here. And basically what we're talking about is like the different ways to improve and optimize AI's responses, right? And like, this is a great diagram. Maybe talk about like the two different types of optimizations, like how are they different from each other?
Well, what we're optimizing for when you ask an LLM a question is the information that you're sending it. So you always hear about the context window length. That corresponds to how much information you can send along with your question that it's going to read through before it gives you the answer. Retrieval augmented generation is all about optimizing what you send in the context window to the LLM. And then beyond that, why people love Llama is they can take it and they can fine tune it. And you can do this with other models as well, but Llama is sort of the most well-documented one. Fine tuning is sort of like, you've graduated from college and now you're getting trained in a particular job, right? Yes. So you're loading into the model specific information and specific formatting that you want it to follow. And so it's a way of constraining that large foundation model into only answering questions in a certain way and mostly restricting it in the way it answers. So in some sense, dumbing it down or making it more focused.
Got it. Okay. And so before you get to fine tuning and RAG, you want to start with prompting. So I wrote some like specific tips here. Let's say there is like a Lululemon customer support chatbot. Like I buy a lot of clothes from Lululemon. I'm not sure if I should admit this, but yeah. So let's say you had to, prompt engineer the thing. Like, what are some basic tips to make this thing respond well with prompting alone?
Yeah, I mean, it's useful to think of the system prompt separate from the main prompt too. Although, if you're using it as a user, you probably won't see the system prompt. If you're using it as an engineer, you see the system prompt. And the system prompt is very much like, you are an expert in fitness clothing. Here are the top 10 reasons why, people should buy Lululemon. And that's all loaded into the system prompt. You want it to be in every conversation, to have that top of mind as it talks to you.
Yeah.
But then if you are a user or you're, again, an engineer writing prompts, then you have these few shot examples that we mentioned, specific examples, and then you want to have it to actually reason through its answer. And you may actually have it do one thing at a time, like you have in your slide there. So multiple steps. So first consider my workout plan. Okay, now recommend what clothes I should buy as a secondary step. And you could even have it like you've prompted to ask me questions about my workout until you have enough information to recommend what I should buy.
Got it. Yeah, I wasn't familiar with like 1, 2, 3, but step 4 is something that you already taught me. I think like actually splitting a long prompt into multiple short prompts, and each one has their own evals, and like kind of like, it's easier for the LM to understand, right? If it only has one task versus like a bunch of different tasks.
Yeah. I heard one person describe it as sculpting. So you're sort of like starting with, you have a foundation model. It knows a little bit about everything. You feed it more detail about your world. Then you're specifically giving it one thing. And it's sort of like, by the time it's completing your question, it's like really obvious what you want it to say. And so that might be, like we said, first, ask me about my workout, and then don't worry about the clothes yet. Let's figure out, like, give you more information once you have all that information. So I always think about that. Every prompt that I'm writing, it's sort of like you want it to just complete your thought at the end of it. And you sort of specify as much as you can so that it's sculpted down to just the correct answer. Can't not give you the right answer. Yeah.
And for splitting complex tasks into steps, like there's a use case of like, the AI asking user for more information, but there's also a way to split into steps initially, like before, like when I ask my first question, like what is a return policy? Like it actually goes through a bunch of conversations with itself, right? Is that how it works?
Right.
Yeah.
So behind the scenes, that question, what is your return policy, could be appended into a prompt by the software on the back end, and that software is adding a prompt telling the that software might load up examples from other customer service chats or FAQs, right? And then it puts that into the prompt, and then it would say, okay, read the FAQs, list the relevant ones. Okay, now format an answer for the user that's relevant to the question that they asked.
Got it. Yeah. Because it probably has information. Like if you build a slew limit thing properly, it probably has information about my order history that maybe I didn't ask it here, but like it probably load that into the context, right? To answer it well. Yeah. Okay, got it. Okay. So before we talk about RAG and fine tuning, like I think prompting is like very tied to evals, or everything's tied to evals, but I think eval, like someone said, eval is the number one skill that PMs need to build. I mean, you're already an expert in evals. so what is an eval? Let's start with that. What is an eval? Yeah,
it's a test case, right? But unlike traditional software test cases, this might be a stochastic one where you're hoping 80% of the time you get close. Like you're not looking for the exact answer all the time, but you're looking for the general answer 80% of the time to pass an eval. That's how I think about it.
And how do you think about these different types of evals? Like, maybe you can walk through each one of them at a high level.
Yeah. Well, first of all, I mean, people shouldn't be surprised if they're not writing evals today. I think it's totally common. Like every business on earth is just trying to figure out how to get AI into their product. Yeah. And then secondarily, once you get something kind of working, you want to add the second thing, but you got to make sure you don't break the first thing. And I think that's when most people say, okay, I need to write some evals, basically test cases to assess, to make sure that I don't break the first prompt as I add another prompt, another use case, or more customer data, or the customer data schema changes or whatever. So totally normal to say, okay, we got AI working in production, say for this chat use case, we want to make sure that if for 100 most common questions that the AI is generally giving a good answer. So now we establish 100 evals for each of those common questions. And then you run the LM and see how it would answer each of those 100 questions. Mm-hmm. And so these 4 types of evaluation here would be how you grade that answer, right? So you could have a human go through and read all 100 answers and make sure that it gave good answers. That'd be kind of painful if you're going to do that with every new product release or every time you change those prompts and change the customer schema or whatever. Or you can do a programmatic eval where maybe you have a program that just tests to make sure that specific words are in those answers. So every time someone asks about return policy, it should mention 30 days. So it could be slightly different every time, but you have a code check that just looks for the phrase 30 days, and that's considered passing. Which I think I would recommend, but again, you still have to write that eval once. A human has to write it, but at least every time you run it, it's the same thing. It's just this easy programmatic check, runs fast. Next thing you can do is take another model and have it grade the answer. So the good news is if you've got a small, fast model doing the customer service chat at this point, or a fine-tuned model, you could use a more expensive model because you're only going to do this 100 times a day or what have you, to actually grade the answers before you upgrade that core prompt. So you use an AI eval, or just, it doesn't even have to be a more expensive model. It could be a different model, it could be a different variation of the model that you've got, just something to sanity check and flag the answers there. So then you're writing another prompt, which is kind of a meta process. So you're writing another prompt to say, if the original question was this, the answer was this, based on this context, does that look right to you? Then yeah, user evals, like you said, this is sort of something that OpenAI made famous with their original GPT launch. They call this reinforcement learning with human feedback, right? So when you're chatting with an AI online and you see the little thumbs up, thumbs down button, that itself can be a data set that's fed back into the training process, or considered evals for the end users to be the ones that are grading the answers for the LLMs. You could also have a process which incorporates that data to gauge how good your LLM is doing, as from one feature to the next.
So with like with programmatic evals, there's like maybe like a yes no answer. Like the story they mentioned when the return policy question is asked, and if it's not, then it fails. But like with the human and the AI evals, like what are you actually grading this thing on? Like let's take the Lululemon thing. Is it like accuracy, tone, or what are you trying to grade this thing on?
Yeah, the common one is hallucinations. Yeah, absolutely, accuracy and tone. I guess under accuracy, so tone was it always friendly and nice, right? And never said anything mean. Can absolutely have a second LLM check that. Hallucination is the other big one, right? You don't want it to recommend a product that you don't sell. So you could have that second LLM first enumerate or list all the products that it recommended to you, and then also provide it a list of the products that it's allowed to recommend to you, and just say you're just having a sanity check. Make sure that the recommendation didn't contain any products that weren't in the other list.
Yeah.
Okay,
so basically like some. Yeah, go ahead.
Split that up line by line if it's got multiple recommendations, and have multiple LLM calls, right? Or incorporate both of those as separate validations. So check one to check the tone, one to check each line is factual, et cetera, as much detail as you want to go into. Yeah.
And these are just like scores out of like 5 out of 10, right?
Yeah. My favorite thing to do, or what seems to work well, is to make it basically a +1 for everything that it finds that's good about what it's evaluating. So rather than just say, choose a score 1 to 10, it doesn't seem to have very good granulation or reasoning for why it's a 6 versus a 7. It's just kind of, it's broadly correct but LLMs are not great at summarizing into a single score. So what I'll do is say, in your example, give it +1 if the tone is correct, +1 if for each correct product that's mentioned. Maybe you'd see -99 if it mentions a product that we don't sell. And then you can parse those scores out using your code, add up the scores, and now you've got a more accurate count out of 10. That's also, by the way, like forcing it to reason a bit, because it's got to list each reason why it thinks it deserves a better score.
Oh, that's interesting. Yeah.
It'll be better at that than just trying to come up with a score without thinking about it.
Yeah, that is great, man. That's something I never heard that before. That's a nice tip. and so you have your 100 test cases, and then you just like do some sort of plus minus score for each of them. Yeah. Hopefully you sum them up, and hopefully the total score is above X. Then it's like a pass or something.
Yeah, exactly. You could add them up in code and provide, have the red alarm bells go off if anything scores less than 50% or whatever you decide is the threshold, but less than 5. That works great for lead scoring. Do that with spreadsheets full of leads for, any grading or the quality of a report or what have you. Just have it give +1 for everything good and -1 for everything bad. Yeah.
And this is like not something that you can just like one done it, right? Like you got to keep improving the evals as you modify the prompt and the other stuff.
Yeah. I mean, I think there's a sweet spot, right? So when you're testing a new AI feature, you might give it a lot to do, and you might test that with users, and you might see whether they like it or not. And then as you start to figure out what that role of that feature, that AI feature is of your application, then you then narrow in on, okay, it's really just doing this one small thing. So in this case, it's just picking an answer from the 100 FAQ answers that we gave it. And therefore you don't need one of those big, large LLMs, and you don't need sophisticated evals. So I think it's perfectly fine to choose something kind of spaghetti against the wall to begin with, And then as it works for users, you write more evals, you narrow in on exactly what it could do. And then, oh, by the way, if you have 10 million users doing that every day, then you would fine tune so that you have a model that does only that. So you've taken this giant foundation model and you've created what's very much a traditional machine learning model that just does one little thing well and reliably.
Oh, interesting. Yeah.
That's the trend. That's the trend that we're seeing, you know.
Like you mean you see users asking it only a particular kind of question, or you realize that it's only actually good at answering a particular type of question, or both?
See users asking a particular type of question, because ultimately you're just trying to build a thing that answers the FAQs and then handle things it doesn't know about. It says, I don't know, and starts the customer chat, right? Don't have it make up answers that it doesn't know. That's a key reason why people fine tune. And I mean, I think, so, you know, there's not that much magic in AI, right? I mean, it seems magic because you haven't read the whole internet like a foundation model has read. So it seems there can be moments of magic, but over time we start to understand why that magic happens. And so we're really just constraining it to do the type of magic that we want to do in that moment, I guess is another way to put it. I'm not relying on an LLM to somehow magically sell me on a workout program for Lululemon in this example. Like it needs Lululemon to seed it with enough information to say why the products are good and why I should use them for my workout still. Yeah.
Yeah. And like you're trying to, like, I think that's another key lesson. Like if you're building like a chatbot, like you don't want to compete against like, you know, ChatGPT or something. Like you're trying to solve a specific use case, not like a horizontal thing. Yeah.
Right.
How about like real quick, like because I struggle with this. Like for human evals, is it better to write a bunch of like ground truth answers manually, or just like have a bunch of humans grade AI's answers? Like, or do you do both? It's like very time consuming. Yeah.
Yeah. Ideally, you have that sort of golden answer set, and you invest in that up front. Once you see that something's going to be part of production and part of, you know, then it's worth investing in. Because you don't want to redo it. So I think that's just a hurdle. When you hit that right stage, you invest in it. And yeah, either you do it internally or there's companies. I don't have one to recommend. I know we've worked with a few. I don't know their names, but you can outsource that, right? And yeah.
One lazy thing I do is you know, I get some fancy AI to generate answer and I manually modify it to the ground truth answer.
Yeah, you have it take all the first pass at writing them, and you just go in and edit them and cut out the outliers. Like, yeah.
I mean, that's what I do for all the internal docs that I write anyway. So makes sense.
Right.
Yeah. What about, we forgot one type. We forgot like adversarial evals. Like you try to ask to make a bomb or something, right? Like you got to try to break it, you know?
Yeah. I think the pattern I'm seeing there is people will use even a separate model before and after they go into the LLM or you know, the main foundation LLM to filter those types of responses. So again, that can be a fine-tuned one. You can get one off the shelf. Meta, we have an open source project called Llama Guard, that if you're an application developer, you can grab that and basically put it into your chain before that request gets into the core code at all to filter it out.
Can you walk through how, like, let's say I ask Lululemon to make a bomb, like it will go to Llama Guard first? Or?
Yeah. Basically, it's a simpler model that doesn't know everything about the world, but it's really good at recognizing adversarial questions.
That might impact like latency or something, right? Does that?
Potentially. That's why it's smaller and hopefully fast.
Okay.
And those could be programmatic checks too. I know there's a system on Bedrock for guardrails, which is largely programmatic, meaning like we have programmatic evals, there'd be programmatic checks. So just using the word bomb might be enough to like take it out. These yoga pants are the bombs, might not get through.
Yeah. It's just like a bad word check, right? That's
right.
Kind of, got it.
Some gradation there, depending on how strict and how slow you want it to be. You can build a custom solution for that. Yeah.
Let's close evals by talking about a recent example where kind of evals went wrong. Are you familiar with like OpenAI's latest GPT model? They had to roll back.
Yeah, because it was too friendly or too cheesy in its text.
Yeah, like they went through the whole eval process. They did like all the mass scoring and like they did like human spot checks and like, you know, some A/B testing. Even did like A/B testing, right? But like it was basically like way too. It was kind of like I'm not sure if I have the right word for this. It was basically, it's basically complimenting whatever you said.
Right.
And because it complimented whatever you said, like even during A/B testing, the people hit like, right? Because like it's like it makes you feel good about yourself. But yeah, but in reality, it was even if you had bad ideas, it complimented that too.
Right. I think this is going to be really tricky. I mean, I put that in the category of the last few model launches have been, supposedly smarter than most humans, right? So how do you hire humans to grade the answers of the LLM? So in that case, it was maybe they didn't have instructions. They were training a happy LLM instead of a really knowledgeable one. The same problem applies when it gives an answer that looks correct, but you don't have the knowledge to know. And I don't know how we're solving that problem other than you continue to have a broader set of evals across all different academic disciplines. You do grounding is what it's called when you'll actually do a Google search, do a web search, and bring back the information that could either match or disprove that answer that it gave, and then evaluate using that.
Yeah.
I think it's fascinating, but I do think it's going to creates more of a need for each company, each corporate use case to have their own evals and understand exactly what right or wrong is for their business. Yeah.
Okay. Yeah. So basically to summarize, like each time you change the prompt or like you change the model, underlying model, or change something, you should like run your 100 test cases, right? And see what happens. That's kind of what the eval is.
Exactly. Yeah.
Yeah. Got it. Okay. Let's keep going. Let's talk about, so let's say like I did prompting and evals and like, I just can't get this thing to work. So now what should I do next? Like how do I decide between reg and fine tuning?
Yeah. So I think it's worth pointing out a few gotchas with rag, first of all, because that could be why it's not getting the right answer.
Yeah.
The first thing is that more information is not better, definitely not always better, and not ever better, right? LMs get confused as easily as they get narrowed in on the right answer, right? So rag, so the point is you can't just throw whatever vaguely relevant information you have at it.
Yeah.
You got to throw relevant information at it. Otherwise it can just kind of confound itself and and it's not really sure what you're trying to, what answer it should go for. So that is a lot of the times the problem. And so in that sense, rag is by no means like guaranteed to give you better answers, right?
It actually make it worse, right? Like make it worse. Yeah,
absolutely. And there's this sweet spot around, okay, is 20 examples great? Is 10 examples great? And is this whole other, what do you call it? Vector stores, which we'll get into in a minute, have been around for over a decade. They weren't really particularly relevant because they're not like the academic research into making sure you get relevant results kind of topped out before LLMs were invented. So just using a vector store, for example, to bring back the 10 most relevant pieces of information to that query, that's still not going to be necessarily sorted in the right order. There's a whole, it's not chunked in the right size. So very highly likely to confuse your LLM as much as give it the relevant information.
Like a good example, to be honest with you, a lot of the web search products with like ChatGPT and these other things, a lot of times I find the answer is actually worse. Like I asked it for like travel advice, and instead of using its like massive knowledge of like everything on the web, it looks for like 3 different links, and I use that instead. So the answer is actually worse,
Right. They're more biased based on those 3 links. Yeah, it's the exact same problem.
Okay.
So there's a whole nother step, right, called rag re-ranking, right? So this is getting quite sophisticated, but so okay, end user asks a question. You can have the first step of the LLM engineer a query so like in that perplexity or deep research example, it'll take the question that you answered, and then it's going to formulate a query, start searching the web for using that query for relevant results, bring those back and iterate like as almost in an agent loop to find the most relevant stuff. But the simplest form of that is called re-ranking. So let's say you did one search, got the 3 pages from the website. You might hit an LLM just to sort those and pull out the excerpts that are most relevant, throw out the rest, and then bring that back into your original prompt chain to answer the end user's question. So RAG rank is a very common thing, using an LM to rank those results, because coming out of a vector store or database, they may not be in the best possible order.
Let's talk about that in a little bit. But like right now, I'm trying to figure out like how do I decide whether to use RAG or to use fine tuning?
Yeah, I think where you have, let's use the customer support example, where you have that 100 FAQs that you want it to reference, that's more of a RAG scenario, because the FAQs may change from day to day. It's specific to your business, but you want the actual answers in that FAQ to be exactly correct for the end user.
Makes sense. Makes sense.
A 30-day return policy, not a 60, 90-day return policy. So you want it to be factual. So pulling that exact factual answer from a database or from a document store, now you've got the exact right answer in there. If you were to fine tune that or train that into an LLM, you're sort of statistically training it into this giant, large neural net. So it's going to be much less specific. Now, you can still do that, but it's also not huge for like my team, but huge for the average business to do a fine tuning experiment. You still got to structure all your input data, run the test, or run the fine tuning training, and redo that every time the data changes. So it's a much more involved and fuzzy, nuanced experiment to run. So, yeah.
So you don't want to use fine tune. You want to use RAG if you want to get the latest source of truth, basically, right?
Right. And determine know what you're giving it. Yeah.
And then fine tuning is if you want to make the model more friendly, or
yeah. And actually, that's a great example. So the first reason you do fine tuning is to affect more the format of the result than the actual data. So make sure it's friendly. One of the experiments we did, or one of the projects we did with a big company, was to just make sure that every time the customer asks a question and it doesn't know the answer, just make sure it says, "I'm sorry, I don't know." And so you're literally like giving it 50 examples where it should know the answer and 50 examples where it doesn't know the answer. And you're just making sure for every time it doesn't know what the right answer is. We're not trying to fine tune what the right answer is. We're just trying to confidently make sure that it will say, "I don't know," if it doesn't know. Right. So that's an example for fine tuning. It's sort of like creatively lobotomizing it, right? So we're like cutting out some of that crazy world knowledge that's in there and making sure it stays on track with our answers. Yeah.
It's like One Flew Over the Cuckoo's Nest. Have you seen the movie?
Yeah. And also, by the way, when you do that, you do it in such a way that it makes it more efficient and runs faster. So it's also cheaper, but there's more engineering effort involved. Yeah.
Okay, but here's a dumb question, right? Like, why can't I just prompt the model to like stop answering questions you don't know anything about? Like, why can't I just tell the model, prompt?
Yeah. I mean, I think most of us have experienced this. Like, the model is like so temperamental, or your prompt and the output can change wildly based on where you move things around, the data in there, right? So it's hard to rely on it. The fine tuning gives you the ability to really be hardcore about how you're lobotomizing that model so it behaves the way you want it to.
I like how you keep using the word lobotomizing. That's great, man. Okay. Yeah. All right, cool. Let's go to let's talk about RAG a little bit. So this is how it works, right? Like can I return this item, and then you look up some documentation, and then you get some content from the documentation, and then you put it into prompt, right? And then you get the LM to like give a better, more friendly answer.
Right.
Like you prompt it. Yeah.
Yeah.
Okay. So the part that I struggle with is like this retrieval part. Because like, theoretically you can just put the whole, like these models now have like a million context windows, right? You can put the whole thing into the context. So why is this better? I mean, I guess it's a lot cheaper to put the whole thing in context, right?
Yeah. Well, no, I mean, that'd be more expensive, because ultimately at the end of the day, if you say it doesn't have to be a vector store, a SQL query would make it even more obvious. So if I can get all the SQL, all the products out of the database that mention yoga with a single SQL query, that is going to be cheap and easy and fast. And I've already, limited it to just the relevant information on each of those products. If I'm slamming 1,000, 10,000 documents in there, now I'm loading that onto a high cost GPU for the LLM to read all those documents from scratch every time. And we're learning what they're about, try to reason about them. So that's an exaggerated case, and those GPUs are the most expensive part of the architecture. So we want to use the LLM as sparingly as possible. Yeah.
That makes sense. But a lot of times it's not a SQL query. It's like this like vector DB thing, right? So yeah. I post some illustrations here.
Yeah.
so like maybe you can like explain like M5 what a vector DB is.
Yeah. This is the mathematical magic that's underlying all of the LMs, which is really, I don't know, it's amazing that much of machine learning is turning real life problems into math problems. And this is a version of that for text. So you can create a vector embedding of a single word or phrase, and which is effectively, or an entire document, or even an image actually. And that's taking that content and representing it as an array of numbers or a vector, where the purpose of those numbers is to separate it geographically in multidimensional space from the other concepts, the other documents and their concepts.
Okay.
So literally, if you vectorized a set of cat pictures and a set of dog pictures, and then visualized it on a 3D plot like this, the cat picture should show in one part and the dog picture should show in the other, right? If you've properly defined and trained a model to do the vector embeddings. Just similar with documents, and this is the tricky part. So if you're going to index your documents, you need to decide if you want to do each document individually, you want to do excerpts from the documents and index that, or you want to do each sentence in there and let try and find the most relevant sentence, or maybe a combination of all three. So I'm going to index the sentences, map them to the documents. And so if you ask the LLM about a concept, it finds the sentences and then pulls the relevant documents and then summarizes the excerpts, right? There's some magic mix in all that.
So let's say I want to index Lululemon's, reference material, right? Like all the policies and stuff. So I run an embedded model through that material.
And you embed all that material into the vector DB. Vector DB is just storing the mapping between those vectors and the individual documents or paragraphs. Yeah.
And then you got to make some decisions about like you said, like how much is each chunk, right? Is each chunk like a paragraph or like a phrase or what? Like,
yeah.
That's complicated, man. Like, how do you decide?
Well, let's take the simplest example would be, let's take 100 documents, or we have 100 paragraphs. The simplest example, 100 paragraphs describing each of those products. Let's just embed those, store them in a vector DB. And then when the customer asks about something, we got to formulate a query that's going to be mapped to the nearest space in that 3D diagram you've got there next to certain products. So if I ask about yoga, it should have that you embed the phrase, I need help with yoga, to the general location geographically that's about yoga pants and yoga shirts and yoga blocks and all the rest of it. So it's just a way of mathematically, geographically creating concepts. There's a really cool concept, example about if you take, because you can deal with these mathematically now that they're numbers. So if you take king minus male plus woman, and then sum those vectors up, the nearest vector, when you sum those all up and navigate the multidimensional space, would be queen, because we removed the concept of a man from it, add the concept of a woman from it, and now it should find the word queen as the nearest one. So that's what blows my mind, is it turns these very abstract concepts into mathematical ones.
Yeah. And you don't really understand how it works, right? Do you?
Well, I mean, it's literally kind of like a machine learning model in and of itself. To create those embeddings, you're, running lots of documents through that talk about kings and queens and yoga, and then you gauge how far away they were from a cluster or whatever, and adjust your weightings of that, whatever, to make them closer. Yeah.
Yeah, it's funny because like humans work on intuition, and like like a 3-dimensional space, I can kind of get it, but in reality, this stuff is like 100 dimensions, right? Then I'm like,
Right.
what's going
Yeah.
on?
I
I
have
don't
no
get it.
visualization for. Yeah.
Okay,
Yeah.
so let's summarize drag. So basically, what you're saying is, well, why don't you quickly summarize like the pros and cons of rag, right? Pros is like it's cheaper, can help out, yeah.
Cheaper and faster, gives you a coarse grain categorization of your documents, captures these semantic terms loosely, so that you can quickly pull out the related documents and paragraphs, whatever, in order to serve them up to the LLM. So basically, it's a quick way to query my text-based or image-based resources, hand the most relevant stuff to the LLM, and then let it do the hard reasoning on top of that.
And I guess the con is like it's just like there's more room for errors. So you gotta figure out if this thing is working properly.
Yeah, room for errors.
Yeah.
You have to take this step in advance of indexing your documents. It's easier than fine tuning, but you still need a system for this. You can find a software as a service to do it for you, but you still, and then the document changes. You still need to maintain that change. You need to update the document. So maintaining the vector stores, just like maintaining a database. Yeah.
Okay. Cool. All right. So that's reg. Let's talk about fine tuning. I had this like pretty good old diagram. Hopefully it's correct.
I love it. This represents pretty accurately my depth of knowledge with fine tuning, but
okay. So I mean, yeah, go ahead.
Mm-hmm. Yeah, basically, LMs are a multi-layer neural net transformer architecture. So there's this, in the LM world, you're also tokenizing and embedding those phrases and concepts on the way in from your prompt, turning them into numbers, feeding them forward through this neural net to hopefully have it predict what the answer is going to be on the other side. So there's multiple layers of neural nets and lots of math that happens on that GPU to predict the best output based on your input. So fine tuning is merely like, so you say you take Llama 4 off the shelf, download it from us. Now you can upload that to your own server and hack that to give only the answers you want it to give. And so there's a process there called LoRa fine tuning, which is the most common one today, which is low rank adapters. So you're basically kind of like hacking in, adding some adapters to that neural net, which simplify it. And then you can set the weights of those adapters such that it constrains the output. And you basically reward it and boost the weights where it gives you a good answer, or decrease the weights where it gives you a bad answer.
Oh, so it's like it's not like you can just give like give it 100 domain specific docs like question and answers and then be like, hey, go fine tune yourself.
No,
you have to modify.
You need evals or a training data set to say, asked about yoga, this is the right answer. Asked about this, that's the right answers. And then you feed that back in and adjust the weights of the model. So that would have to encompass the contents of your docs, which is exactly why you don't want to do it daily or weekly or monthly.
So you have to adjust the weights of the model like a human has to adjust the weights of the model and then run it again.
Oh no, there's code to do that. It'll gravitate towards an answer by adjusting the weights. So you run through multiple epochs of training data to gravitate till you have your model kind of behaving the way you want it to behave. That's an automated process, but is not simple. Meaning you could accidentally go too far, right? And now it starts to lose information about the world that you wanted it to have.
Got it.
Yeah.
So it's kind of like an upfront investment. Like you gotta maybe invest like a month or two and then like a bunch of money to fine tune it, right?
Yeah, I think first you get the evals, and then you do the fine tuning. Yeah.
Okay. But then once you fine tune it, then it's like lobotomized. So then like you don't have to prompt engineer it as much. Like it's like it's easier, right? Yeah.
And it should be cheaper too, because that LoRa process will quantize a lot of the weights, so you can shrink it down that way.
So remind us. So this is like only needed like maybe like 10% or less of the time, right? Like so remind us like what are some. Can you remind us what are some example use cases again where this actually makes things a lot better?
Yeah, I mean the customer service. If you were AT&T actually fielding all of those customer support chats, a very good idea. Of the 100 or 1,000 most common cases, you could train your own model to generate answers, initial answers. So the customer support rep human just has to approve the answer, right? And so it's very good at producing canned answers for nearly, for much cheaper than it would be to do that in real time. Let's see. I think the hallucination case I mentioned is another one with another customer where they wanted to just make sure that it doesn't know the answer. It's always going to say, I don't know. And
okay, it just doesn't. Got it. I mean, that sounds very simple, but yeah, it's pretty important when
or the guardrail models too, right? That you can fine tune so it only knows about saying no to bombs and really doesn't know much about anything else.
Got it. I wonder if there's a way to, with the AT&T thing, I don't know if you're saying this, but like, dude, I really hate like sitting on a call, pressing a bunch of numbers, trying to get to the human. I wonder if there's a way to like prompt hack this thing so that it sends me to the human right away. I guess fine-tuning tries to prevent that,
Yeah, probably. I have a hat from a meetup that says ignore all previous instructions. You could ask it like, what are you?
Yeah, you can make up some like emergency situation where like, I have to get the internet working because of XYZ.
Right. Yeah.
I don't know.
Yeah. Those are exactly the type of cases that would inspire fine-tuning and guardrails. Yeah.
Got it. Okay. All right. I think that's a lot of slides we had. So let's talk a bit more about Llama and open source to wrap up. So why don't we talk a little about Llama 4 and also like, what is the key difference between open source and proprietary, and like why does Meta think open source is gonna be the right solution here?
Yeah. Meta wants to make sure that everyone in the world has access to AI. That it's not locked up behind OpenAI or controlled by Anthropic even. And that was what motivated them to go open source to begin with. And you can see, so that's also what's leading the features in Llama as well. So Llama 4 is multilingual, multimodal, meaning speech, video, images, and then there's just performance updates, like the fact that it's mixture of experts. I think this is our first mixture of experts model, which is part of that LLM architecture I was talking about, the layers of neurons. There's a way to segment it so different areas of the neural net are experts in different topics.
Okay.
And so that's another area of active research, is you might be able to fine tune that down so that you're just using select experts and therefore can run faster, better, cheaper. So yeah, it's all part of the theme of making AI pervasive and making sure that everyone on Earth has access to it.
Got it. And do you think open source is going to keep closely trailing closed source, or like be equal at some point? Or I mean, even OpenAI is thinking about doing open source, right? It's
a great question if it will catch up.
Right.
I mean, I think, if you just think about all the other open source software I've used in my lifetime, from WordPress to Linux, et cetera, it's never really been cutting edge, but it's been because it has to serve some broader audience. So I would guess that we continue to trail behind. But Meta's excited to do it because it wants to make things like the Ray-Bans work great for everyone, and so that's got a very high bar, right? So incentivized to make it good.
Yeah, I mean, I think Meta is all about scale. Like, I think there's like 1 billion people using Meta AI already. You don't want a world where like the richest people have access to the best models, right? So that's
right. Exactly.
Yeah. Okay. Adam, any closing words of advice for PMs and other AI builders here? Yeah.
I think I wouldn't have too much FOMO about the newest, greatest thing. We didn't even touch on agents or some of the latest, greatest concepts. And I guess my advice to people would be not to have too much FOMO about that. These patterns are very rapidly emerging. If you broke your brain and your team trying to figure out RAG 2 years ago, you might regret it now, right? Like it wouldn't have been worth the effort. But the best you can hope for is to at least get your engineering teams to try these features, get used to calling LLMs as part of the architecture, get something basic into production, and then write your evals, consider how to make it efficient as you grow. Prior to Meta, I was advising startups. So I worked at a startup studio where we created 40 startups over the last 10 years. And the last couple of years was all AI startups. And really, the advantage there, whether it's a new company or a new feature that you're rolling out, you get to try something very targeted that's really going to leverage the intelligence of the LLM to disrupt some market or just make a new great feature that your users will love. And so I think that's where you should focus. Don't get overly intimidated about all the new stuff that's emerging. Just make it so your team feels comfortable using LMs, and then I think you get hooked on the drug of like, oh, well, we could use an LM for this. We can use an LM for this. Oh, wouldn't this make a great feature, right?
I mean, yeah, you can make a lot of money with like a thin wrapper around an LM. You don't need like all this fancy infra. In fact, it probably holds you back if you build too much of it.
Right.
Yeah. Okay. Awesome, man. Where can people find you online, or do you want people to find you online? Or
please look me up on LinkedIn. Adam Loving.
Cool. All right. Thanks for this AI course, man. I'm gonna call you Professor Loving from now on. So thanks so much. Yeah.
Happy to take it. I could talk about this stuff all day. Thank you so much for having me. It's just such a great time. As an engineer that has been coding for so many years, I've always wanted these type of features to have machines that could do even the most basic farm raising. It's amazing. So I look forward to talking to people about it.
All right, Adam. Thanks so much, man. Yeah.
Take care. Talk to you soon.